Grade 9 Sound Part 1 NCERT Textbook Questions and Answers. Page number 162, question number 1. How does the sound produced by a vibrating object in a medium reach your ear? Answer. Sound is produced by vibrating objects. When an object vibrates, it vibrates the neighboring particles of the medium. These vibrating particles then force the adjacent particles to vibrate. It creates disturbance in the medium and produces a series of compressions, region of high pressure, and rarefactions, region of low pressure in the air. These make the sound wave that propagates through the medium and finally reaches our ears. Page number 163, question number 1. Explain how sound is produced by your school bell. Answer. When the school bell vibrates, it forces the adjacent particles in air to vibrate. It creates disturbance in the medium. When the bell moves forward, it pushes the air particles in front of it and creates compression, region of high pressure, and when the bell moves backwards, it creates rarefaction, region of low pressure. The continuous forward and backward movement of bell produces a series of compression and rarefaction. This makes the sound of a bell to propagate through the air. Page number 163, question number 2. Why are sound waves called mechanical waves? Answer. Sound waves require material medium for their propagation. Hence they are called mechanical waves. Page number 163, question number 3. Suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? Answer. No, I will not be able to hear any sound because sound requires a medium for its propagation and there is no atmosphere or medium on the moon. Page number 166, question number 1. Which wave property determines A. Loudness, B. Pitch? Answer. A. Loudness is determined by amplitude. B. Pitch is determined by frequency. Page number 166, question number 2. Guess which sound has a higher pitch, guitar or car horn? Answer. Pitch of guitar sound is higher because it has higher frequency. Page number 166, question number 1. What are wavelength, frequency, time period and amplitude of a sound wave? Answer. The distance between two consecutive compressions or two consecutive rarefactions is called the wavelength. It is represented by lambda. The number of complete waves or oscillations produced in 1 second is called frequency of the wave. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called the time period of the wave. The maximum displacement of the particles of the medium from their original mean positions during the propagation of a wave is called the amplitude of the wave. Page number 166, question number 2. How are the wavelength and frequency of a sound wave related to its speed? Answer. The relation between wavelength, frequency and speed of wave is wavelength into frequency. Page number 166, question number 3. Calculate the wavelength of a sound wave whose frequency is 220 Hz and speed is 440 meter per second in a given medium. Answer. Frequency equals 200 Hz, speed equals 440 meter per second, wavelength equals speed by frequency equals 440 by 220 equals 2 meter. Page number 166, question number 4. A person is listening to a tone of 500 Hz sitting at a distance of 450 meter from the source of the sound. What is the time interval between successive compressions from the source? Answer. Frequency equals 500 Hz. The time interval between two successive compressions is equal to the time period of the wave. Therefore, required time interval equals time period equals 1 by frequency. So, time period equals 1 by 500 equals 0.002 second. Page number 166, question number 1. Distinguish between loudness and intensity of sound. Answer. 1. Loudness is a measure of the response of the ear to the sound. It is determined by its amplitude. The amount of sound energy passing each second through unit area is called the intensity of sound. 2. Loudness is dependent on the sensitivity of the human ears. Intensity is independent of the sensitivity of the human ears. Page number 167, question number 1. In which of the three media, air, water or iron, does sound travel the fastest at a particular temperature? Answer. Sound travels fastest in solid medium, that means sound wave will travel fastest in iron. Page number 168, question number 1. An echo returned in 3 seconds. What is the distance of the reflecting surface from the source given the speed of sound is 342 meter per second? Answer. Speed of sound equals 342 meter per second. Time taken equals 3 seconds. So, distance travelled by sound equals speed into time equals 342 into 3 equals 1026 meter. Hence, distance between reflecting surface from the source equals 1026 by 2 equals 513 meter. Page number 169, question number 1. Why are the ceilings of concert halls curved? Answer. The ceilings of concert halls are curved so that sound after reflection reaches all corners of the hall and is audible to each person in the hall. Page number 170, question number 1. What is the audible range of the average human ear? Answer. The audible range of the average human ear is 20 Hz to 20,000 Hz. Page number 170, question number 2. What is the range of frequencies associated with A. Infrasound, B. Ultrasound? Answer A. Infrasound has frequencies below 20 Hz. B. Ultrasound has frequencies higher than 20 kHz. Page number 172, question number 1. A submarine emits a sonar pulse which returns from an underwater cliff in 1.02 seconds. If the speed of the sound in salt water is 1531 meter per second, how far away is the cliff? Answer: time taken by the sonar pulse to return, t equals 1.02. Speed of sound in salt water, v equals 1531 meter per second. Distance of the cliff from the submarine equals speed into time equals 1531 into 1.02 equals 1561.62 meter. Distance travelled by the sonar pulse during its transmission and reception in water equals 2 into actual distance equals 2d. Actual distance equals distance of the cliff from the submarine by 2 equals 1561.62 by 2 equals 780.81 meter. Page number 174, question number 1. What is sound and how is it produced? Answer: sound is a form of energy which produces a sensation of hearing in our ears. It is produced due to vibrations of different objects. Page number 174, question number 2. Why is sound wave called a longitudinal wave? Answer: sound wave is called a longitudinal wave because the particles of medium move in a direction parallel to the direction of propagation. Page number 174, question number 3. Describe with the help of a diagram how compressions and rarefactions are produced in air near a source of sound. Answer: when a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called compression. This compression starts to move away from the vibrating object. When the vibrating object moves backwards, it creates a region of low pressure called rarefaction. As the object moves back and forth rapidly, a series of compressions and rarefactions is created in the air. These make the sound wave that propagates through the medium. Page number 174, question number 4. Cite an experiment to show that sound needs a material medium for its propagation. Answer: take an electric bell and an airtight glass bell jar, connect it to a vacuum pump. Suspend the bell inside the jar and press the switch of the bell. You will be able to hear the bell ring. Now pump out the air from the glass jar. The sound of the bell will become fainter, and after some time the sound will not be heard. This is so because almost all air has been pumped out. This shows that sound needs a material medium to travel. Page number 174, question number 5. Which characteristic of sound helps you to identify your friend by his voice while sitting with others in a dark room? Answer: the quality or timbre of sound is the characteristic by which we can identify the person by his voice. Page number 174, question number 6. Flash and thunder are produced simultaneously, but thunder is heard a few seconds after the flash is seen. Why? Answer: flash and thunder are produced simultaneously, but the flash is seen first and then the sound is heard. This is because the speed of sound in air is very less than the speed of light in air. Speed of sound in air equals 334 meter per second. Speed of light in air equals 3 into 10 raised to 8 meter per second. Page number 174, question number 7. A person has a hearing range from 20 Hz to 20 kHz. What are the typical wavelengths of sound waves in air corresponding to these two frequencies? Take the speed of sound in air as 340 meter per second. Answer: speed of sound V equals 344 meter per second. Frequency V1 equals 20 Hz. Frequency V2 equals 20 kHz equals 20 into 10 raised to 3 Hertz. Wavelength lambda equals speed by frequency. Wavelength lambda 1 equals 344 by 20 equals 17.2 meter. Wavelength lambda 2 equals 344 by 20 into 10 raised to 3 equals 0.0172 meter. Page number 174, question number 8. Two children are at opposite ends of an aluminium rod. One strikes the end of the rod with a stone. Find the ratio of time taken by the sound wave in air and in aluminium to reach the second child. Answer: speed of sound in air equals V air meter per second. Speed of sound in aluminium rod equals V aluminium meter per second. Length of the rod equals x. Time taken in air T1 equals distance by speed equals x by V air. Time taken in aluminium rod T2 equals distance by speed equals x by V aluminium. Required ratio T1 is to T2 equals V air by V aluminium. Page number 174, question number 9. The frequency of a source of sound is 100 Hz. How many times does it vibrate in a minute? Answer: frequency equals 100 Hz. Number of vibrations in 1 second equals 100. Therefore, number of vibrations in 1 minute equals 100 into 60 equals 6000. Thus, the source of sound vibrates 6000 times in a minute. Page number 174, question number 10. Does sound follow the same laws of reflection as light does? Explain. Answer: yes. Sound and light follow the same law of reflection given below. 1. The incident sound wave, the reflected sound wave, and the normal at the point of incident all lie in the plane. 2. The incident sound wave and the reflected sound wave makes the same angle with the normal to the surface at the point of incidence. Page number 174, question number 11. When a sound is reflected from a distant object, an echo is produced. Let the distance between the reflecting surface and the source of sound production remains the same. Do you hear echo sound on a hotter day? Answer. An echo is heard when the time for the reflected sound is heard after 0.1 second. Time taken equals total distance by velocity. On a hotter day, the velocity of sound is more. If the time taken by echo is less than 0.1 second, it will not be heard. Page number 174, question number 12. Give two practical applications of reflection of sound waves. Answer. Two practical applications of reflection of sound waves are 1. Megaphones, 2. Stethoscope. Page number 174, question number 13. A sound wave travels at a speed of 339 meter per second. If its wavelength is 1.5 centimeter, what is the frequency of the wave? Will it be audible? Answer. Speed equals 339 meter per second. Wavelength equals 1.5 centimeter equals 0.015 meter. Therefore, frequency equals speed by wavelength equals 339 by 0.015 equals 22,600 Hertz. This frequency is greater than 20,000 Hertz, so it is not audible. Page number 174, question number 14. A stone is dropped from the top of a tower 500 meter high into a pond of water at the base of the tower. When is the splash heard at the top? Given g equals 10 meter per second squared and speed of sound equals 340 meter per second. Answer. Height s equals 500 meter. Acceleration due to gravity g equals 10 meter per second. Initial velocity u equals 0. Using the equation of motion, s equals ut plus half at squared. 500 equals 0 into t plus half into 10 into t squared. 500 equals 5t squared. So t squared equals 100. T equals 10 seconds. Now, time taken by splash sound to reach the top of the tower equals distance by time equals 500 by 340 equals 1.47 second. Therefore, time after which flash is heard equals 10 plus 1.47 equals 11.47 second. Page number 175, question number 15. What is reverberation? How can it be reduced? Answer. The repeated multiple reflections of sound in any big enclosed space is known as reverberation. The reverberation can be reduced by covering the ceiling and walls of the enclosed space with the sound absorbing materials like compressed fiberboard, rough plaster. Page number 175, question number 16. What is loudness of sound? What factors does it depend on? Answer. Loudness is a measure of the response of the ear to the sound. Loudness depends on the amplitude of the vibrating body and the sensitivity of human ear. Page number 175, question number 17. Explain how bats use ultrasound to catch a prey. Answer. Bat can produce high-pitched ultrasonic waves. When these waves strike on their prey, it is reflected back to the bat as an echo and detected by their ears. The nature of reflections helps bats to recognize the nature of the prey and distance at which its prey is present. Page number 175, question number 18. How is ultrasound used for cleaning? Answer. The objects to be cleansed are put in cleaning solution and ultrasonic sound waves are passed through that solution. The high frequency of these ultrasound waves detaches the dirt from the objects and hence the objects are cleaned. Page number 175, question number 19. Explain the working and application of a sonar. Answer. Sonar stands for Sound, Navigation and Ranging. It is a device that uses ultrasonic waves to measure the distance, direction and speed of underwater objects. It consists of a transmitter and a detector and is installed in a ship or a boat. The transmitter produces and transmits ultrasonic waves. These waves travel through the water and after striking the object on the seabed get reflected back and are sensed by the detector. The detector then converts the waves into electrical signals which are properly interpreted. The time interval between transmission and reception of the signal is also noted. The distance d of the underwater object is calculated from the time t taken by the echo to return with a speed v. Then the total distance 2d travelled by the ultrasound is 2d equals v into t. Page number 175, question number 20. A sonar device on a submarine sends out a signal and receives an echo 5 seconds later. Calculate the speed of sound in water if the distance of the object from the submarine is 3625 meters. Answer. Time taken to hear the echo t equals 5 seconds. Distance of the object from the submarine d equals 3625 meters. Total distance travelled equals 2d equals 2 into 3625 equals 7250 meters. Speed of sound in water equals distance by time equals 7250 by 5 equals 1450 meters per second. Hence, the speed of sound in water is 1450 meters per second. Page number 175, question number 21. Explain how defects in a metal block can detect using ultrasound. Answer. Defects in metal blocks do not allow ultrasound to pass through them and they are reflected back. This fact is used to detect defects in metal blocks. Ultrasound is passed through one end of a metal block and detectors are placed on the other end. The defective part of the metal block does not allow ultrasound to pass through it. As a result, it will not be detected by the detector. Hence, defects in metal blocks can be detected using ultrasound. Page number 175, question number 22. Explain how the human ear works. Answer. The human ear consists of three parts. That means the outer ear, middle ear and inner ear. A. Outer ear. This is also called pinna. It collects the sound from the surrounding and directs it towards the auditory canal. B. Middle ear. The sound reaches at the end of the auditory canal. There is a thin membrane called eardrum or tympanic membrane. The sound wave sets this membrane to vibrate. These vibrations are amplified by three small bones: hammer, anvil and stirrup. C. Inner ear. These vibrations reach the cochlea in the inner ear and are converted into electrical signals which are sent to the brain by the auditory nerve, and the brain interprets them as sound.